Lastly, in this section, we're going to talk about the randomized block design. And let's say we were doing an experiment with Alden High School students. Okay? And I were to give you a list of all the students, and you randomly select the students. For certain questions, you got to be careful that you don't have maybe too many girls, or too many boys, or too many 12th graders, and not enough 9th graders. So creating a block would be basically separating into two blocks, like male, female, or separating them into 4 blocks, like 9th, 10th, 11th, 12th, and then randomizing your sample, or randomly selecting the students. I think we talked about this in the last section about strata. How did we say it? Stratified is how we said it before. So maybe separating the students first, and then deciding if we want to have 12 9th graders, 12 10th graders, 12 11th graders, 12 12th graders in the study, and then randomly selecting those 12 people in the 9th grade, 12 people in the 10th grade. And that sometimes can help really make sure that you're getting the best random example that you can, or the random sample of students that you can. So randomizing isn't all that. It's usually separating the students or separating the groups into something that they have in common, and then picking from there randomly. Another way, and another neat way, is a thing called matched pairs design. And I thought this was pretty cool. In order to see how someone is affected by something, you can actually have a subject repeat the study and maybe once receiving the placebo, and once receiving the active pill. And what this does is this actually takes out any other variable that goes into play. Because if the person was healthy already, then they're healthy taking the placebo, and they're healthy taking the active pill. If someone was unhealthy before, then you would see how it was affected, their body was affected by the placebo, as well as how it was received by the active pill. You'd actually have to repeat the study, and given a little time in between, you wouldn't be able to do it, you would do it one after the other, but not at the same time. You can't do it simultaneously, take a placebo and the active pill. But this would take out other variables, other lurking variables that could change the study. It also gives you double the data, and it excludes the differences that the individuals have. You could also match the people as close as possible. So if you have a study where you're giving a drug and you're giving a placebo. Maybe you would have a male that's 40 years old. In this group, you'd have a man that's 40 years old. They don't have to be the same man. Obviously, they can't be the same man. But they would be a man 40 years old. Maybe you would have someone who was Asian descent. An Asian woman that is 30. And you'd also have another Asian woman that was 30 in this study. And trying to keep matches so that both groups would have an equal amount of people that resemble each other. They don't have to be the same person. Another way is, this is super easy when you think about non-living things. Non-living experimental units. Like the book gave a good example of tires. Okay, tires that you're going to fill with air and tires that you're going to fill with nitrogen. How do I spell that? E-N? Nitrogen. Okay, so you take the Goodyear tire. The Goodyear R125. You fill it with air. And you take the Goodyear tire R125 and you fill it with nitrogen and you compare them. Makes perfect sense. And then you do the Michelin tires and you do other tires, Firestone, I don't know many, but and you take one of each and put them in each one of those groups so that it's very easy to compare which is actually, and it's the actual tire being used in both places. So that one is a good one to do because it's non-living. It's easier to do.